Just got enough battery to make it through. So what I would do is divide by that as a goal. You could distribute, but why? Why would you do this? And then the last thing is,
Well, just move x1.
yeah, add x1 over. This step should not have been difficult. This is algebra stuff, right? Add x1 over, so I get x1 minus f of x1 over f prime of x1 equals x. But what is this really going to be? When I find the x-intercept, what's that going to be? That's going to be my
Your second thing.
second guess. So what am I going to call it?
X2.
No way. That's crazy. And then guess what I'm going to do? I'm going to take x2, plug it in here. So what's x2 minus f of x2 over f prime of x2? That equals
X3.
x3. And I really want to make sure you understand. Bless you. I could take x2, do all this work again, but of course I'm going to end up at the same, that it's going to look the same. It's just going to have an x2 in it. So why do all this? You just put x2 into the form that I already know is the one that works. All right, so let's try this for cosine, and let's use that same first guess, the 3.59. Let's try it. Let's see what happens. All right, so what does this mean? What do I need then? I need a guess. I need the function evaluated at that guess. I need the derivative, and I need the function's derivative evaluated at the guess, right? So let's kind of build what we need. So if I'm given cosine, to find its roots, that specific root, my guess, let's use the same guess we were on. That's the 3.59 was the guess there. Is that cool? Can you guys see that's the first entry in that list of guesses? So x1, let's say, is 3.59. So what's f of 3.59? Somebody help me. What units are you in? By the way, what units?
Radians.
Radians, thank God. Yes. Degrees are made up shit. Humans made them up to make them make more sense.
Negative 0.901.
In fact, so hold on to that. So we can get that. I like it. So that's cosine of 3.5. Let me just leave it like that. Because the more you round, the worse your approximation gets, right? Is everybody cool with that? And look here. Does that look about, what did you say, negative 0.9 something?
Yeah. Yes.
There, negative 0.9 something, right? Okay, cool. We're just seeing if this little widget thing works. What's f prime of x? Negative sine x. So what's f prime of 3.59? Negative sine of 3.59, right? So I'm going to just step through one step with you, and then I'm going to show you how the calculator can automate this for you. You just have to be able to set up the equation, right? So to get x2, I'm going to take x1, 3.59. Now I'm just using this equation. This is what Newton's method is right there. That's the heart of Newton's method right there. So to get x2, I'm going to take x1 minus f, so this will be cosine of 3.59, divided by negative sine. So can I just make that a plus? Is that cool? Mm-hmm. Sine of 3.59. So this is really cotangent, if you want. Let's see if we get what they got for their second guess. We didn't miss anybody. Let's see. Got it. All right, cool. What'd you guys get?
5.66, whatever
And what was their second guess?
5.66.
Kick-ass. So that's where they got it from. They did this procedure that's built into this widget thing, whatever you call it, and that's how it got there. So to get x3, you would just put 5.66 blah, 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 plus cosine of 5.66 blah, blah, over sine of 5.6 blah, 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 and it would come out to be 4.25 blah, blah, blah. And every time you do it, as long as your first guess is good enough, it's refining the guess.
They're just following that formula.
Exactly. So let me show you in the calculator how it can automate this. So you don't have to do this, good Lord, how, a million times.
Yeah, I was gonna ask you, like, if we were doing it by hand, how would you know when to stop?
Do you notice immediately how I couldn't possibly expect you to do it by hand? Because do you know what the sine of 3.59 is?
Oh, no.
All right, so you're not going to do this by hand. So we are using the calculator to do things like tell me what the value of sine is at a point, right? So the last few minutes I got, let me show you how this works. It's really kind of cool. Go away, Explorer. There's double sine. Some of you guys, that looks vaguely familiar. Maybe last time you logged in a few months ago. Let's see. I won't name names. You can name your own name, yeah. Alright, so here's the beautiful thing. Remember the A and S button down here.
Answer?
Not anus, but yeah, A and S answer. A and S. No, it's the answer button. Watch how this works. Some of you guys might know this from... You were able to do this with older calculators, but this is kind of nice because you can see the whole expression at once. So what I do is, I get myself started with 3.59. I put 3.59 in, and I hit enter. Yay! But now A and S has that in it. So now if I put this form, wherever you see 3.59 here, I'm going to put A and S. And actually, let me bring this back to, well, so we've got this set up, right? So anywhere I see that 3.59, I'm going to say, where'd it go? So A and S plus cosine A and S divided by sine A and S. Now watch. So that's everything, right? Okay. Enter. So there's that. Now, if I just hit enter again, what does A and S have in it now? 5.668. I don't have to redo it. It's automatically updated to that. So if I hit it again, it's going to reevaluate this. But now this is the value of answer. And you just keep going until it doesn't change anymore. Isn't that cool?
Yeah.
Let that be cool. Let that be so cool. So here's before you go, there's a little handout. It kind of captures the ideas of what I was just talking about. I've got the. Like, so
Very, very white. This is high quality picture, dude. Like,
yeah, it is. It's nice, man.
this is some like white stock, whatever.
You pay extra.
Okay.
That's a different paper right here.
Buy.
Small paper.
Or, you know what?